and welcome back to our video for example 3, where we're going to sketch the graph of 1/2 tangent of the quantity x minus pi over 4 minus 2. And that means we need the anchor points of the tangent function. The parent graph of tangent, we're going to just sketch that down here real quick so we can grab some anchor points. Here's our turning points, 1 and -1. And then we'll put our 4 quadrantal angles along the x-axis. So this is pi over 2, then pi, 3 pi over 2, and 2 pi. And recall that tangent is the quotient identity of sine over the cosine of the angle. So everywhere that cosine is equal to 0, the tangent has asymptotes. And cosine is 0 at pi over 2 and at 3 pi over 2. Then where sine equals 0, since that's in the numerator, the tangent has zeros. And that would be at the origin and pi and 2 pi. And then between these points of intersection with the x-axis at the increments of pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, we're going to have our turning points. So tangent is positive in quadrant 1. So it's going to equal 1 at pi over 4. It's negative in quadrant 2. And so it equals -1 at 3 pi over 4. Then quadrant 3, 5 pi over 4, tangent is positive, so we'll be back at 1. Then 7 pi over 4 is the 4th quadrant where tangent is negative. And then we bend through these anchor points to make a wiggle for our parent graph of tangent. So I can use these anchor points as I go across. Now I don't want to exclude my pi over 4 values as anchor points because those show me where the turn is when I wiggle through these center points. So I'm not just going to grab zeros and asymptotes because I won't know the shape of the wiggle. I'm going to grab these pi over 4 increments as well. So starting at the origin, that would be 0, 0. Then at pi over 4, the tangent is positive 1. At pi over 2, I have a vertical asymptote, which is undefined. Then at 3 pi over 4, I'm at -1. And then at pi, I'm back to 0. And that would be one full cycle of the parent graph of tangent because tangent has a period of pi units. So next, let's identify the A value. That's our vertical shrink in this case. Since it's positive, there's been no reflection in the x-axis. And we're going to multiply each of these y values by 1/2. The x's will stay the same. So 0 times 1/2 is 0. Then we have pi over 4, and 1 times 1/2 is 1/2. Then pi over 2, and undefined times anything is still undefined. So that stays an asymptote. 3 pi over 4. And then -1 times 1/2 is -1/2. And pi, and then 0 times 1/2 stays a 0. Okay, then we're going to identify the B value, and B is the coefficient on x. That's a 1. And dividing by 1 doesn't change anything, so we'll go ahead and skip that column. That brings us to the phase shift, h. H is positive pi over 4. And that means we're going to the right 4 units for the phase shift. Okay, so we're going to add pi over 4 to each of these x values. 0 plus pi over 4 is pi over 4. Then pi over 4 plus pi over 4 is pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. Then 3 pi over 4 plus pi over 4 is pi. And pi plus pi over 4 is 5 pi over 4. And that's our phase shift to the right, pi over 4 units. Now we have our vertical displacement. K is a -2, so that's going to displace our graph down 2 units. So all of the y values will decrease by 2. The x's will stay the same. So we've got pi over 4, comma 0 plus -2 is -2. Then pi over 2 and 1/2 plus -2 is -3/2. Then we've got 3 pi over 4 and undefined plus or minus anything stays undefined. So that's a vertical asymptote. Then pi, and we're taking -1/2 minus 2 or plus a -2 is going to be -4/2. Minus 1 is -5/2. So -2.5. -5 over 2. And then 5 pi over 4. And 0 plus -2 is -2. So we can go ahead and plot our asymptote then at 3 pi over 4. And this is pi over 2, so this would be 1 pi over 4, 2 pi over 4, 3 pi over 4 is our vertical asymptote. Oh, that didn't get very straight. Okay, then we have at pi over 4 a -2. At pi over 2, -1.5. Then at pi, we're down at -5.5, or 5/2, -2.5. Then 5 pi over 4 is -2. And now we're back at that same pattern again. So we would come up here to -1.5, followed by a vertical asymptote, and then back down to -5/2, and then -2, and so on. Coming back the other direction, we're going to be at -5/2 on the y-intercept, followed by a vertical asymptote at -pi over 4. Then at -pi over 2, we'll be at -3/2. Then -2, then -5/2, followed by an asymptote. And notice how this cycle just keeps repeating until we get to the end of the graph. And so as we sketch our wiggles between these asymptotes, we got to go through those guide points. And this is hard to do with the digital pen, but I think we got the idea. So we're staying between these asymptotes, approaching but not touching or crossing them, and wiggling through those guide points. Okay, our vertical stretch or shrink, that was the A value. This was a vertical shrink in this case of 1/2. There are no asymptotes. There's no amplitude. The asymptotes are x equals And our first non-negative asymptote is at 3 pi over 4, and then plus or minus k times the interval to the next vertical asymptote. And these are 1, 2, 3, 4 tick marks apart. Each tick mark is pi over 4. So they are pi units apart. The period is pi divided by b, and our b is 1, so the period is pi. The domain is all real numbers except where the function is undefined, and that's at the vertical asymptotes. So x is not equal to 3 pi over 4 plus or minus k times pi. And the range is the same for all tangent and cotangent graphs. It's negative infinity to positive infinity. That's our set of all real numbers. So if you wanted to check this with your graphing calculator, you would put your calculator into radian mode and then plot your function in the y equals button, 1/2 tangent of the quantity x minus pi over 4 minus 2. Adjust your window settings to go from negative 2 pi to positive 2 pi in the x direction with an x scale of pi over 4. And then y minimum is negative 5, y maximum is 3, and this will be your graph. And then you can use the trace function to plot some points and make sure they match with what we came up with in our table. So you're going to want to pause the video next and complete this checkpoint problem in your notes packet. 1/2 cotangent of 2x and then a vertical displacement up 1. And you can resume the video when you're ready to go over that together. So our anchor points for cotangent are listed here. Then we're going to multiply the y coordinates by the a, which is 1/2. That's a vertical shrink of 1/2. Then we're going to divide all of the x coordinates by the b. That's the coefficient on the x, which is a positive 2. The h here is a 0. There is no phase shift. And the k, our vertical displacement, is a positive 1. So that's going to shift everything up 1. And then we'll plot these points at the end of the table on our graph, and this would be the picture of the transformed cotangent function. It has a vertical displacement up 1 unit, a vertical shrink of 1/2. There is no phase shift. The period is pi divided by b, and since the b is 2, that makes our period pi over 2. So these are very tall, thin wiggles in there in the cotangent graph. The asymptotes determine the domain. Our first non-negative asymptote is at 0 plus or minus k times the period, which is pi over 2. And then the domain is x is not equal to each of those asymptotes. And our range for tangent and cotangent is the set of all real numbers, so the interval negative infinity to positive infinity.